We are starting with exercise 8 of limits. First question, limit x approaches towards pi, 2 plus 2 cos 2x, 2 plus 2 cos x, x minus pi. This 2 might not be printed in your worksheet, so please make that change. Okay. Now x is approaching pi. If you put x as pi over here, pi minus pi is 0. Here we cannot do any simplifications by which we can avoid that 0 in the denominator. So let x is equal to pi plus h. As x approaches pi, h will approach 0. Okay. So this will be limit h approaching 0, 2 plus 2 cos pi plus h upon pi plus h minus pi. Limit h approaching 0, 2 plus 2 cos pi plus h. Now pi is over here, plus h. Plus is anti-clockwise. So in this quadrant, cos is negative. Okay, so it is minus sin h. Minus cos h, sorry. Okay, cos will remain cos because it's on the x-axis upon h. Okay, take 2 common over here, 1 minus cos h upon h. Why minus? Because this plus into this minus becomes minus. Okay, 1 minus cos h. Okay, there is a 2 already in the problem. 2 sin square h by 2 upon h. Okay, so this 2 is separate and this is half angle, 2 sin square h by 2 upon h. Okay, so limit h approaching 0, 4 sin h by 2 upon h, sin h by 2. Okay, now there is only one h. So this is h by 2. We'll make this h by 2. How? Divide and multiply by 2. Now this sign does not have h beneath it because we had only one h which was assigned to one of the signs. So the angle of this sign is h by 2. So down also h by 2, up also h by 2. Okay. So this particular part which I have highlighted, this is 1. So 4 into 1 into 1. Okay. This 2 I'm writing over here. This is 2. Okay. Then this h is remaining. It did not get cancelled out with anything. So put the value of h as 2. We don't have any other option. And this 2 over here. So the answer is 0. Okay. Next problem, question number 2. Limit x approaching towards pi by 2. 1 plus cos 2x. Pi minus 2x the whole square. Pi minus 2x the whole square. Okay. Now if you put pi by 2 over here in place of x. Okay. So this will be 0. Denominator will be 0. And of course, like the previous problem, we cannot do any manipulation to avoid this situation. So let x is equal to pi by 2 plus h. As x approaches pi by 2, h will approach 0. We're changing the limits using RHL. Limit h approaching 0, 1 plus cos 2 pi by 2 plus h upon pi by 2 minus 2 pi by 2 plus h the whole square. Don't take too many shortcuts. Okay. So this equal to limit h approaching 0, 1 plus cos 2 into pi by 2 is pi plus 2 into h is 2h. Pi plus 2h upon 2 into pi by 2 is pi, minus into plus is minus h the whole square. Pi plus 2h. So cos pi plus 2h is minus cos 2h, and this pi and pi is getting cancelled. So this is minus h the whole square, which is h square. So limit h approaching 0, 1 minus cos 2h upon h square. 1 minus cos 2h is 2 sin square h as per half angle. Limit h approaching 0, 2 sin h upon h the whole square. Limit h approaching 0, 2 into 1 square. Okay. Uh, let's not write this because we are putting the value, substituting the formula over here, sin h upon h. H is approaching 0. So answer is 2. Okay. Third one, limit x approaching pi by 2, 1 minus sin x, pi by 2 minus x the whole square. Here also, if you put x as pi by 2 in the denominator, it becomes 0. Any other substitution manipulation is not quite possible. Okay. So even if we do divide by x and multiply by x over here, then to the denominator will be 0. Because what about this x? That's the fight. Okay. No other option but to change limits using LHL or RHL. As x approaches pi by 2, h approaches 0. Okay. So this is equal to limit h approaches 0, 1 minus sine pi by 2 plus h upon pi by 2 minus pi by 2 plus h the whole square. Limit h approaching 0, sine pi by 2 plus h. Sine pi by 2 plus h is cos h, and this is gone, and this minus h the whole square is h square. So 2 sine square h by 2 upon h square. Okay. So I'll just group the squares. 2 sine h by 2 upon h the whole square. 2 h by 2, and this also h by 2 upon to the whole square. Okay. So divide by 2, multiply by 2. So this thing will be 1. Okay. So 2 into 1 by 4, that is 1 by 2 is the answer. As h approaches 0, h by 2 also approaches 0. Okay. That was question number 3. Let's go to question number 4. Limit x approaching pi by 2, cos x, pi by 2 minus x. Let x is equal to pi by 2 plus h. As x approaches pi by 2, h will approach 0. So this is equal to limit h approaches 0, cos pi by 2 plus h upon pi by 2 minus pi by 2 plus h. Cos pi by 2 plus h. In this quadrant, cos is negative, y-axis minus sin h, and down also we are having minus h. Okay, when you open the bracket, sin h upon h is 1. Sin h upon h is 1. Okay, yeah. So that was question number 4. Let's go to question number 5. Limit x approaching pi by 2, 1 minus sin x pi minus 2x the whole square. Okay, so let x is equal to pi by 2 plus h. As x approaches pi by 2, h will approach 0. So this is equal to limit h approaching 0, 1 minus sine pi by 2 upon pi minus 2 pi by 2 plus h the whole square. Sine pi by 2 plus h is cos h. Okay, this 2 and this 2 is gone. So pi minus pi is gone and it's minus h in the box bracket. Minus h in the box bracket. So that is minus h the whole square. Limit 2 sine square h by 2 upon h square. Negative square is gone. Okay, so this thing we have solved in the previous problem. So this I leave it up to you. Okay, just practice this well. Then let's go to question number 6. Limit x approaches towards pi, 1 minus sine x by 2, pi minus x the whole square. Let x is equal to pi plus h. As x approaches pi, h will approach 0. 1 minus n pi plus h upon 2 upon pi minus pi plus h the whole square. See, every time I'm putting a bracket up because there is a minus sign. And I've seen in the exams and tests, such kind of things you people don't do, which can lead up to some errors. 1 minus sine pi by 2 plus h by 2. This I'm splitting over here upon minus h the whole square. Now sine pi by 2 plus h by 2 is sine pi by 2 plus theta is cos theta as per this. Okay, plus cos theta. Okay, but then already there is a minus sign. Okay, h square. Now 1 minus cos h by 2. The half of h by 2 is h by 4. Half of h by 2 is h by 4. So this will be 2 sine square h by 4. Limit h approaching 0. 2 sine square h by 4 upon h square. Limit h approaching 0. 2 sine h by 4 upon h the whole square. So divide by 4, multiply by 4. Okay, now this part becomes 1. So this is equal to 2 into 1 upon 4 the whole square. You can calculate this. H approaches 0. H by 4 also approaches 0. Okay, h by 4 also approaches 0. So that was your question number 6. Let's go to question number 7. Limit x approaches 1. 1 minus 1 upon x sine pi x minus 1. Okay, so first we'll take LCM over in the numerator. X minus 1 upon x the whole upon sine pi x minus 1. So now see, technically speaking, this is also the denominator, this is also the denominator. So this is also denominator, this is also the denominator. So we'll take that x down. Limit x approaching towards 1, x minus 1, x sine pi x minus 1. Okay, that x is equal to 1 plus h because we can't do anything else. Okay, you can multiply and divide this with pi x minus 1. Okay, but then what about this x? This x will remain. Okay, and if that is 0, then the denominator is 0. Okay, so change the limits. Let x is equal to 1 plus h. So limit h approaching 0, 1 plus h minus 1, 1 plus h sine pi x plus 1. So pi into 1 plus h minus 1. Okay. Limit h approaching 0. So there is h in the numerator, 1 and 1 gone, sine pi h. Now you can multiply and divide with pi h. This will be 1. This h and this h is getting cancelled. Okay. So just put the values now. Okay. This is 1. This is 0. H approaches 0. So pi into h will also approach 0. Okay. Yeah. Next problem, that is question number 8. Limit x approaching a, sin x minus sin a, root of x minus root of a. Okay. Now there is root minus root in the denominator, so you can rationalize this. You can also rationalize after changing the limits, not a problem. And sin minus sin formula also will apply. Sin c minus sin d. So 2 cos c plus d by 2 sin c minus d by 2. Rationalize the denominator. Limit x approaching towards a, 2 cos x plus a by 2 sin x minus a by 2 root x plus root a upon this into this will be x minus a. Now see, I just realized that changing the limits is not really required. We did not write x is equal to a plus h because look at the terms now. 2 does not have any problem. If you put x as a over here, cos a plus a upon 2, that is cos a, not a problem again. This again is not a problem. Okay. The problem is only with these two terms, or rather this term x minus a. If you put a over here, then denominator will be 0. But then for this particular sign, the angle is x minus a by 2. So we can easily make this x minus a by 2, divide and multiply by 2. Okay. So this problem, ideally, we have not done any changing limits. Okay. It can be done, but then no need of doing that and increasing the number of steps. Okay. So this part, I'll group it with sign, divide and multiply with 2. Okay. So limit x approaching a, 2 cos x plus a by 2 sin x minus a by 2, x minus a is already there, divide by 2, multiply by 2 into root x plus root a. Okay. Now this part is 1. Okay. Now we'll put the values. Okay. Root a plus root a, which is 2 root a. Okay. But then wait, here there is a catch. I just realized this right now. We cannot write this as 1. We cannot write this as 1 because x is not approaching 0. It has to approach 0, something x minus a. Let's check 1 second. X approaches towards a. Okay. So x minus a approaches to 0. I took a on the other side. So x minus a upon 2 will approach 0. Yes, we can apply. We can apply. Correct. Sorry. Otherwise, simple thing, just do changing limits. Okay, but then that will increase the length of the problem. So see, x minus a by 2 will approach 0. So x approaches a, meaning what? X minus a by 2 will approach 0. Okay. Or rather, if you're getting confused, what I will do is I'll just change the limits for your own simplicity. Okay. It will be more simple for you. Instead of doing this divide by multiply by 2, I'll just change the limits over here. Let x is equal to a plus h. X approaches a, h will approach 0. Now there won't be any confusion. Okay. Limit h approaching 0. 2 cos a plus h minus a upon 2 sine a plus h minus a upon 2. This is plus, sorry. And this is root a plus h plus root a. Okay. A and a is gone. Here again a and a is gone. Now we'll group this h with the sign term. We'll group this h with the sign term. Okay. So divide by 2, multiply by 2 over here. Limit h approaching 0 cos 2a plus h by 2. Why 2a plus h by 2? Because a plus a will be 2a into sine h by 2 upon h. So these are the terms which are left. Now divide and multiply by 2. Okay. This thing will be 1. Now put the value of h as 0 in the remaining terms. 1 upon 2. So now h approaches 0, so h by 2 also approaches 0. That's why this is 1. Okay. So 2 cos a half 2 root a. 2 gone. 2 root a cos a. Okay. So I would recommend do this to avoid any confusion. After this step, you can just change the limits. Okay. Question number 9, we have already done in the previous recording of question number of exercise 7. We have done that over there. Question number 10. Sub question 1. Limit x approaches pi by 2 cot x upon pi by 2 minus x. Let x is equal to pi by 2 plus h. Okay. As x approaches pi by 2, h will approach 0. So limit h approaches pi by 2 cot pi by 2 plus h, pi by 2 minus pi by 2 plus h, cot pi by 2 plus theta is tan minus tan theta, because cot in the second quadrant is negative. So minus tan h, and this also will be minus h. Minus minus gone, tan h upon h is 1. Okay, right? So that was your question number 10 sub question 1. 10 sub question 2. Limit x approaches pi Sine 3x upon sine x. So before changing the limits, what I would do is, see, you can divide and multiply by 3x here and x over here, but then x is approaching pi, x is not approaching 0. You cannot apply the formula. Okay. So 3 sine x minus 4 sine cube x upon sine x. Take sine x common. 3 minus 4 sine square x. Sin x gone. Now there is no denominator. Put the value of x as pi. So sine pi is equal to sine 180 and sine 180 is 0. So this minus 4, 3 minus 4 into 0 the whole square, which is equal to 3. So no formula, nothing. Only one simple formula of triple angle helped us over here. Okay, question number 11, 1, 2, and 3 will start right now. Question number 11, sub question 1. Limit x approaches pi by 2. Cos 3x plus 3 cos x upon pi by 2 minus x the whole cube. Okay. Let us apply that triple angle formula first. 4 cos cube x minus 3 cos x plus 3 cos x. Okay, this formula I have applied over here. Pi by 2 minus x the whole cube. So this and this is gone. Let x is equal to pi by 2 plus h. As x approaches pi by 2, h will approach 0. Okay, so put x as pi by 2 plus h. So limit h approaching 0. Okay, so x is pi by 2 plus h. 4 cos cube pi by 2 plus h upon pi by 2 minus pi by 2 plus h the whole cube. Okay, now cos pi by 2 plus theta plus h is equal to minus sin h using this method. Okay, so limit h approaching 0, 4 minus sin h the whole cube, because there is a cube over here, and cos pi by 2 plus h is minus sin h. This pi by 2 and pi by 2 is gone, so minus h the whole cube. Limit h approaching 0, 4 minus sin h. I'll group the cubes. Minus sin h upon minus h the whole cube. Okay, so 4 into 1 cube, which is equal to 4. Okay, sin h upon h is 1. Let's go to the second sub question. Ten, 11 sub question 2. Limit x approaching pi sin 3x minus 3 sin x the int upon pi minus x the whole cube. It's similar to the previous problem. Triple angle formula will make it easy. 3 sin x minus 4 sin cube x minus 3 sin x upon pi minus x the whole cube. So 3 and 3 is gone. minus 4. Okay. I can group the cubes here as well. Not a problem. So I did it over here. Okay. Whenever you get a chance of grouping some terms, you do that. Let x is equal to pi by 2 plus h. As x approaches pi, h will approach 0. Now, some students might have a doubt that why are we not dividing and multiplying with x? You can do that, but then what about this x then? It will remain, and pi minus pi is 0. Okay. So, limit h approaching 0 minus 4 sine, let me just check, sine pi plus h, pi minus pi plus h. The whole cube. Limit h approaching 0 minus 4 sine pi plus h will be minus sine h, and this is also minus h. Okay. So pi and minus is gone. Okay. Minus gets cancelled. Sin h upon h is 1. So the answer is minus 4. One last problem from this exercise. Question number 12 we have already done from the worksheets in the previous recording. So question number 12, question number 11, so question 3. Relatively a big problem. X approaches pi by 6. Root 3 sin x minus cos x upon x minus pi by 6. Okay. Let x is equal to pi by 6 plus h. As x approaches pi by 6, h will approach 0. Okay. So this is equal to limit h approaching 0 root 3 sine pi by 6 plus h minus cos pi by 6 plus h upon pi by 6 plus h minus pi by 6. So this is gone. Now numerator we have to do compound angle formula here and here. Okay. So limit h approaching 0 root 3 okay, that root 3 I've written over here, this root 3. Down there is h. Now sine pi by 6 is 30. So sine 30 cos h minus cos plus cos 30 sin h plus cos 30 sin h. Yeah, and here this is also 30. So cos 30 plus h, cos minus sin, cos 30 cos h minus sin 30 sin h. Now put the values. Half cos h plus half sin h. Root 3 by 2 cos h plus root 3 into root 3. 3 by 2 sin h minus root 3 by 2 cos h plus half sin h upon h. So this and this term is gone. Root 3 by 2 root 3 by, 3 by 2 sin h plus half sin h is equal to 2 sin h. So limit h approaching 0, 2 sin h upon h. Sin h upon h is 1. So this is equal to 2. So that is the end of this particular exercise. The problems which I have not done in this exercise is in the previous recordings while doing exercise number 7, part number 2. You can refer that. Okay. Thank you.